And last but not least, rounding us out for the day is Saad. Saad is passionate about building products in the areas of cloud, virtualization, containers, and distributed systems. He's also super passionate about Kubernetes and automation. Welcome, Saad.
Thank you for having me. All right, hi everyone, and thank you for joining the session. Like Sharon mentioned, my name is Saad Malik, and I'm the CTO and co-founder of Spectro Cloud. And so today we'll be talking about GitOps to manage your Kubernetes clusters, specifically looking at Argo CD and Cluster API. So a little bit more about myself, like Sharon mentioned, I'm very passionate when it comes to technologies like containers and Kubernetes and distributed systems. I was part of an early cloud startup called Clicker Technologies, where we focused on multi-cloud application management. And that is actually where we first started working with Docker containers and orchestration platforms like Apache Mesos and Kubernetes. So Clicker was acquired by Cisco in 2016. And at Cisco, we worked very closely with our customers on their digital transformation and their adoption of cloud native technologies like containers and Kubernetes. So in 2019, along with other key executives from Clicker Technologies, we left to start Spectro Cloud to really make Kubernetes accessible and approachable for everyone. Now, with that, let's talk about how do we align Kubernetes infra lifecycle with the lifecycle for application workloads. So looking at the Argo CD typical workflow, and again, I know this is the last session for the conference. I'm sure you guys have heard it many times already, so we'll go through it rather quickly. But as one of your application developer builds a really interesting feature, they go ahead and merge that into their code Git repository. Now, through the power of a continuous integration pipeline, there are two artifacts that are generated. One is an actual Docker image, which is promptly pushed to a Docker registry. And then the other, of course, is a Kubernetes manifest specification. It could be either a direct manifest or a Helm chart that is pushed into a Git repository. This special Git repository, of course, is being read by Argo CD. Any changes that happen in this Git repository are automatically then pushed to any designated cluster, whether they're Helm charts, customized, or even raw manifests. So there are, of course, other examples in workflows with Argo CD, but this is a typical one for a dev pipeline. Now, the question that I have is, where does a Kubernetes cluster come from? So in many cases, there is a separate team, generally a DevOps or an IT operations team, which is responsible for the lifecycle and management of the Kubernetes cluster and its lifecycle. Typically these days, that entire cluster lifecycle is automated, either using some manual scripting or using Terraform. And generally the scripting and the Terraform will have all the necessary plumbing to provision an end-to-end cluster. This would include provisioning the underlying infrastructure. As an example, on a public cloud like Amazon, this would be creating the networking constructs like the VPCs, the subnets, the security groups. And then, of course, after all the core infrastructure is provisioned, provisioning the actual EKS cluster and any node groups that sit on top of it. So once a cluster is fully up and running, like I mentioned before, the previous workflow applies, right? Essentially, you still have the same mechanism of being able to add your code into a Git repository, and then those applications are deployed into the cluster that is being provisioned and maintained by a separate team. So why is this a problem? Well, if you start thinking about Kubernetes, if you're still in the experimentation phase, maybe it's okay. However, as you start moving into early productization, there are a few aspects that need to be considered. While Kubernetes has become that common control plane, a common operating system for running containerized application, it itself is a very complex platform that requires significant effort to both provision and to operate. All of that complexity on how do you run it and operate it essentially becomes a responsibility for the DevOps or the IT operation teams to maintain in their scripting or in the Terraform. Now, the complexity, of course, skyrockets as you start thinking about managing multiple clusters and especially across multiple clouds. So whether you're using scripting or Terraform, it also is a different language than what you're used to when it comes to application deployment that are generally based on Argo CD using YAML structures to deploy and maintain these clusters. And again, because the tooling is different, requires a different set of people and skill sets to learn and operate. So instead of having a separate workflow for managing your Kubernetes lifecycle and your applications, wouldn't it be nice if you could somehow manage even your Kubernetes infrastructure via GitOps? Right? How would you be able to connect Argo CD with Kubernetes, specifically for it to manage the Kubernetes infrastructure lifecycle? So this is where Cluster API comes in. And for those of us who are not really familiar with Cluster API is a declarative way for you to manage your Kubernetes cluster. It is governed by the CNCF Cluster Lifecycle Special Interest Group, has a massive community, and is being adopted by virtually all modern Kubernetes management platform, including Google Anthos, VMware Tanzu, and even our company, Spectro Cloud, really heavily relies on Cluster API and its capabilities. One of the unique capabilities of Cluster API is its unique plugin architecture that allows us to support virtually any environment, any infrastructure. So what's unique about Cluster API is its declarative management. Similar to how you manage other resources in Kubernetes clusters, you describe the entire state in terms of its cluster, its configuration that is being able to provision. This specification becomes a blueprint or a template used to orchestrate and manage the cluster. And because the APIs are really Kubernetes-style APIs, it works really well with GitOps and, of course, with Argo CD. So Cluster API does provision end-to-end multi-master conforming clusters across any environment and lets you perform all the day one and day two lifecycle tasks, such as your scaling operations, your upgrade of your Kubernetes clusters. And because it does manage the end-to-end lifecycle from the infra all the way up to the Kubernetes layer, it also has some very powerful resiliency capabilities, where potentially if one of the nodes that the Cluster API is managing becomes faulty, Cluster API can automatically replace it by provisioning a brand new node to take over. So how does Cluster API work in the back? So it's a Cluster API, it's a Kubernetes project built using operators and controllers. There are high-level abstractions or CRDs that define the cluster aspects, the machine deployment, the account configurations. Now, for each of the different environments or clouds that it supports, it uses a plugin called a provider. These provider, of course, manifest into different behaviors. In the case for Amazon, the implementation would be to provision EKS clusters with node group, and the volumes are EBS volumes. Right? Similarly, other clouds will, of course, have other types of implementations. So with Cluster API, right, this would really unify the workflow in terms of both the Kubernetes infra as well as the application workflows themselves. Right, so now the dev and IT operations using a declarative specification into a Git repository can specify which clusters to provision, what is the upgrades to happen, any scaling operations, and through the power of Argo CD would detect these changes and then push these specifications into a management cluster that hosts the Kubernetes to host the Cluster API specifications. So we're going to jump into a short demo where we will provision a brand new Amazon EKS cluster using Cluster API. We'll show the actual end-to-end lifecycle for that. And then also we'll show a quick demo using a bare metal provisioning of an actual cluster using Cluster API. And of course, this whole thing would be driven directly through Argo CD. So the very first thing I want to show is that I have a management cluster that is running on Argo CD demo spectrocloud.com. This right now has two different Argo CD applications, a sample app for guestbook and another app called K8s clusters. If I drill down into this K8s cluster and I look at the details for this applications, notice that it's looking at a specific directory or a specific repository, GitOps-Argo CD, at the folder K8s clusters. So let's jump into that. I'm going to go into the actual repository and go into the K8s clusters directory. Right, from here, there's at this point no YAML, there are no configurations, any clusters to provision. What we're going to do is we're going to go into the directory and copy the configuration for provisioning an EKS cluster. And I'll describe in a moment all the different properties that are specified here. We're going to go back into the K8s clusters directory, add a new file, and then we can call this cluster aws3.yaml and paste the structure here. So this is the specification for Cluster API. It's describing a single new cluster to be provisioned, And by the way, for the infrastructure in this case, use the AWS managed control plane. This is the specifications to say, use the provider for EKS. If we take a look at the EKS specific configurations, you can specify either dynamically provision the resources or statically place them on a specific network. So in this case, we're specifying to use the network here. And then additional properties like machine pool configurations can also be specified. If we were to commit this into the actual Git repository, and we were to go back into my Argo CD, and obviously Argo CD, every minute it refreshes the manifest, but you can force a refresh by clicking on refresh. Notice that it detected a change. It's now loading in the latest specifications, and hopefully within a few seconds, right, we should see all the various aspects of the actual cluster API resources come in. I'm going to refresh the screen. Right here, notice that it's provisioning now the cluster CRD object, the machine pools, and all the other configurations. If I go into the AWS managed control plane, and if I click on the events tab, give it a second. Right, it's going to show all the behind the scenes of provisioning that's happening for the cluster. We can log even directly into the EKS control plane here, and if I can refresh, notice that there is now an EKS3 control plane that is in a creating state, and Cluster API will actually wait for the entire cluster to be fully provisioned before it proceeds on with the next operations. And with that, I'm just going to real quickly also show how to provision a mass cluster. So with that, I'll go back into the GitOps Argo CD directory, into Capi cluster, go into the BAK. There is a cluster-mass.yaml. I'm going to go ahead and click on the raw file. And again, this is going to be provisioning an end-to-end bare metal cluster using a canonical MAS, which is a bare metal management interface. There are some uniqueness here in terms of specifying, what are the actual machine image template to use, what are the specifications for the bare metal system. But if I copy this configuration, and if I go back into the actual cluster, go to Capi clusters here, we can add a new file. And I'll say this is going to be cluster mass2.yaml. I'll paste the content and I'll commit it. And then within a few seconds, inside of my Argo CD, it's going to detect there's a new modification change here. And then, of course, start provisioning also the mass cluster behind the scenes. So Cluster API really makes it very easy to not only provision, but manage the end-to-end lifecycle of your clusters. Okay, so what are some of the benefits, right, of managing the infrastructure via GitOps, right? It's the same benefits that you're getting with managing application using GitOps. Git really becomes a self-documenting repository, so you get complete traceability into the operations performed, who, what, when. Super easy to recover. In most cases, if something was, you misconfigured something or you specified a wrong scaling number, just revert to the previous commit, and via GitOps will revert to the previous state of the cluster. And depending on your organization, you may also have very advanced workflows in terms of who is allowed to make operational changes into your infrastructure. You use your GitHub or GitLab or whatever CI and Git repository process you have to make those workflows easy. And finally, because it's just relying on Argo CD and the YAML-based specifications, it works identical to how you manage your applications. So, but that's not the end of the story. Right? As customers find their journey and adoption of Kubernetes, there are problems that Cluster API does not address. For example, Cluster API only manages the core 4 layers, the operating system, Kubernetes, networking, and so on. But who manages the additional add-on services from your logging, your monitoring, security, and other aspects of that? Right? There are other day-to operations beyond the Cluster API support. Everything from providing role-based access control within the cluster, cost control, backup, restore, and logging and monitoring solutions. All of these different capabilities need to also be addressed. Now, either you build it manually, or this is where the selling part comes in. Our product, Spectro Cloud Palette, does. Right? As I mentioned before, the Capi is foundational for Palette. In fact, we are one of the key startup contributors to Cluster API. And what we do with Palette is we extend Cluster API to cover the entire stack, all the layers from the 15 to 16 different integrations when it comes to logging, monitoring, service mesh, and so on. We make it easy to integrate it all as a declarative model. It caters to all the day-to functionality from your backup restore, your quota control, and any additional enterprise-grade controls you may need. And a third selling point for us is that Palette is not opinionated. In fact, you can bring it into any existing environment. Even if you have your existing OpenShift or legacy technologies, we can work with this cluster technologies. And we work with any distribution, any environment, in any cloud. So let's take a look at a complete workflow now with Palette in the picture. So Palette, of course, integrates with Cluster API, but now holistically from a singular declarative model that your DevOps and IT engineers are maintaining, you not only get the aspect of provision of clusters, but also managing all the day-to operations, right? Especially as you move to production across multiple clouds, makes it really easy end-to-end. And so with that, that's the final slide that I have. I would say, come and talk to us wherever you are in your cloud native and Kubernetes journey. Whether you are starting now or moving your containers to production, we can really help you simplify the way you manage your Kubernetes environments. By the way, if you are interested in Palette, we are running a promotion for ArgoCon users, where we're providing them with free access for a few months on any Kubernetes project they may have. And beyond Palette, if you guys have any questions on Kubernetes or Cluster API, myself and my team would be more than happy to help out. So feel free to email me at saad@spectrocloud.com or tweet at me at Saad Malik. So thank you so much. That's our presentation.
Right. And that's a wrap. All of these recordings, all of these talks will be on demand shortly. I invite you to take a look again, listen, ask questions in the chat, and we look forward to seeing you again at ArgoCon 2022.